Good morning, everyone. So, my name is Dr. S. Gurraj. So, I'll take the topics of molecular modeling. So, second year, you have the syllabus. So, today we will go with the discussion of your syllabus. So, what are the syllabus you have in your pharmacoinformatics second year, third semester? So, how many papers you have? So, what are the description of paper? So, brief information about your papers, right? I'll share the information of your syllabus copy right now. Right. So this is the paper one. So you have the four papers. So first one is a database management, sources and scripting languages. So in this you have the 4 units. So first unit is chemical information sources and searches. Another one database design and management. The next one is a data sequencing and mining, and another one fourth unit is scripting languages. And the second paper you have the computational chemistry, molecular modeling and its application. So in this the two sections are there. So unit 1 and 2 are the computational chemistry 1 and 2, and the third and fourth units are drug designing methods, the 1 and 2. So one is ligand based methods, another one is structure based methods. And after that you have the two papers of synthetic organic chemistry, synthetic reagents and advanced and NMR. And the fourth paper is modern organic synthesis. The two different electives are there: advanced natural products and intellectual property rights. But two organic papers are there in your syllabus. And my topics are data sequencing and mining in the paper one, and another 2 units of drug design methods, ligand based, and another one is drug design method, structure based. And I also take the another topic which is as chiral drugs of your paper fourth last unit. But today we will go with the discussion of the first 2 papers, that is a database management and scripting languages. And another one is computational chemistry, molecular modeling and its applications to you, right? So here, so what are the sequence and what is the link between these units and how these units will help you to learn the informatics area? So this is the one thing. So in this, the paper one is database management, sources and scripting languages is there. So in this first unit is chemical information sources and searches. So in this you can go with the syllabus of introduction to information sources and searching strategies. What are the tactics for searches and advantages and limitations of the computer searching? So how to search? So how many types of methods are there available in searching? So one is key-based bibliographic searches, or general searches, or chemical connectivity searches, are based on structure searches, means 2D structure or 3D structure, are based on the chemical structure as well as the properties, are based on the 3D shape of the structure, and searching based on the synthetic reactions, means how the synthetic reaction proceeds, what are the specific compounds or classes of the compounds, are searching the chemical abstracts, means the components abstracts. And another one is types of publication. This is most important because whenever you want to go for a search of your articles, research purpose or review purpose, if you want to go for search, so how many types of journals are there, what are these, how you can identify the informations, what are those, everything will be here, how to search and what are the types. If you know the basic thing of types, then only you can go for search and you can easily analyze what information you are seeing. So types of journals, what are the technical reports, what is patent, what is conference paper, what is dissertation, and how many types of electronic, whether that is a print version or electronic version, means soft or hard copies of the publications are available. And different types of databases, means database means collective information where once it is stored in a rows and columns area, that is called a database generally. So how many types of databases are, what are the public database, what is a paid database? Public database means it is a freely available databases. If it is a paid database, means we have to pay some information to retrieve, to pay some amount to retrieve the information. So that is a paid services. So what is a web-based cross-platform solutions? So these are the different types of cross-platform solutions, means where we have to submit the web-based information, where we have to submit some information of ours to calculate or to retrieve through the databases, to calculate in the servers of the online. So servers are remotely established. So from that area, we are using some services. So those are called as web-based cross-platform solutions for chemoinformatics or bioinformatics, whatever the informatics. These are the sister subjects, means interdisciplinary subjects of the informatics, right? And the second unit is database design and management. So in this database design and management, you will go through with the computers, basic computers. Some of the people, you don't know the basic computers. So you have to know the basic computer, how to operate, what are the operating systems available, what is database. So how the database is going to help you in your works. So how many types of diagrams, means database, how they will maintain. So each and every information will be, so different types of models, different types of diagrams, entity relational diagrams. So what are the normalization methods to establish the data in a specific form, and introduction to the different languages of SQL, DDL, DML, DCL, and TCL. These are the different query languages of how to maintain a database. Structured query language, that is a data definition or data manipulation, data cleansing, and truncated languages. So these are the different languages. How to use these languages to establish a database, means creating the database, information searching in between databases, and using the SQL commands. So what are the built-in functions, means math functions, string manipulation functions, different functions are available. And how to improve our query performance, means how to find out a specific information from a large data. So by using group by or having the class, so what are the cursors it is using, and how to inform, how to store the information in a database. So these everything comes under here. As well as you have the MySQL. So in this MySQL, you have to configure the MySQL software in your running system, whether that is a Windows system or a Linux system. So how to process the data or information into the computer, means by taking a flat file, means normal text file, and those information will be stored. How to store those information into a database, means as a table or columns, rows. So how to enter the data. So these information comes under data processing. And data presentation, how to present the information, means different types of graphical informations, are bar charts, are pie charts, different types of presentations of computing. And the last one is the distributed processing, how to distribute the information in a different, means a single multiple table will be used in multiple areas, or multiple table parts, means a specific columns or rows will be used and collected the information and to establish one single form. So those will be taken care in database design and management, because these informations are mostly required whenever you enter into your database servers. How they will establish or how they will store the information, based on those only you can easily retrieve your information. So because of that, you require to learn the database design, how the design databases are stored, how it is designed, how it is maintained. If you know those things, then only you can easily retrieve your information, whatever the required information or desired information, right? And the next one is data sequencing and mining. This is my topic, right? Introduction to data mining. So what is data, what is data, what is the mining? So what is the working principle behind the data mining, and what is the architecture form of the data mining, and difference between data mining and machine learning technique. Different types of techniques are there at present. Machine learning techniques, machine learning is not to learn ourselves, but we have to train the machine how to analyze. So that is called machine learning techniques. So in these techniques, what are the methods of learnings are there, supervised and unsupervised, right? What are the applications of these machine learning and supervised unsupervised techniques in a data mining or QSAR, that is the quantitative structure activity relationship. You people know the SAR, structure activity relationship of benzoic acid derivatives generally. So that is the similar one. The y is equal to mx plus c equation will be analyzed here. So that is a QSR, quantitative measurement. And the another one is data visualization. So whatever the analysis has been done in sequencing and mining, so those information will be how we can project our information in a chart. So that is a visualizing the data mining models. And different types of analysis are there. That is one is decision tree, means how we have started the process, how we have ended. So how many decisions we have taken from initial to termination point. So what are the information what we gain, whether that is a positive or negative. So which side of the branch of the decision tree is a true and false. So those informations, how to establish a decision tree, how to analyze a decision tree, that will be taken care in decision tree area. And the last one in this topic is data warehousing. So warehousing means, generally warehouse means the large amount of the information, means large amount of the databases are stored in a specific area, then that is called as a warehouse. So data warehouse. So how to mine in that area, how, what are the different analytic technologies are there, so what are the different types of comparison of different models using visualization techniques, those will comes under the data sequencing and mining area, data mining area, right? This is the concept where you have to go through in all your topic areas, in every area of the work or research. So these components will be available, or you have to go through with these components only, you can conclude your works, everything, right? The another topic is the scripting languages. So why we need to learn a glance of scripting languages is, whatever the softwares we are using in this informatics area, so those softwares will be built in a Linux based commands, shell based commands, or shell scriptings, or it may be Perl scriptings, or it may be C++ or Python libraries or Java libraries. So these will be used to establish the languages or softwares of ours. So if we have this minimum knowledge of these softwares, because some softwares will have the command based analysis, so it will give a pack of command based content, so where we have to type the commands like DOS commands, and we have to run the programs of the scripts, then only we can get the information. If you know the minimum knowledge of the script, then only you can easily manipulate those scripts and you can retrieve the information, or you can go for calculations. And some softwares are having the GUI, means the pointer cursor will be there, small windows will be there, if you click on a button it will generate a pop-up, then you can browse the information, you can submit the data, and automatically it will generate. So some softwares are available in a scripting languages. So here you have to learn with what are the conditions, bash shell scripting, Linux editor, right? Perl scripting, MySQL connection, how the Perl scripting used to connect the MySQL database server, so how to input the data, how to retrieve the data. So these contents will be learned in this scripting languages area, right? The second paper is computational chemistry. The computational chemistry and molecular modeling and its applications. So in this computational chemistry 1 and 2 and there, drug designing methods 1 and 2 are there. So in this computational chemistry 1 and 2 are the topics where you have to go with the molecular minimization, means energy parameters and the coordinate parameters of the molecules, macromolecules means proteins and DNAs, micromolecules, those are the small molecules that are ligands or drugs, you can say drugs. So small organic molecules, how to analyze those molecules, how to establish those molecules, what is the bond angle, what is the bond energy, how the energy will be calculated, how it is optimized. It means how the bond lengths, torsion angles, and bond angles will be minimized or established in this area. So these will be taken care in the computational chemistry 1 and computational chemistry 2, that is the Schrodinger wave equation, molecular mechanics, quantum mechanics, and how the wave functions will be identified, what are the force field contents. So everything will be force field content, energy minimizations, means how many types of energy minimizations are there, what is the highest, what is the lowest minimum energy, means first order minimization, second order minimization, or derivative type of minimizations. So in these different types of methods are there, that is a steepest descent, conjugate gradient, or conformational search procedures, so geometry based optimization procedures. So these comes under minimizations or force field applications. And another topic here, it is a molecular dynamics. So in this dynamics, you can go with the molecular with Monte Carlo methods, or simulative methods, or qualitative methods. So different types of molecular dynamics methods will be available. So how to analyze those physical equations to calculate an energy of a small molecule. So because if it is a molecule, if the molecule is in a lowest energy state, means that is a stable molecule. That is a basic fundamental criteria. So how to obtain a small molecule with the lowest energy conformations. So these are the different methods will be available in these two units. And another topic is MIME, that is the drug designing methods of the ligand based. Another one is structure based. So in these two types of drug designing concepts are there. One is a ligand based analysis, one is structure based analysis. In a ligand based method, whenever you don't have any theoretical information, whenever you don't have any practical evidence of a protein or biological receptors, means biological information, then we will go with the small molecules. So how many molecules are available synthetically, synthesized molecules. We will collect the information of synthesized molecules and then we will start the SAR, structure activity relation. I have to go with analysis of the molecules, and then we will get some IC50 values, means activity values of the molecules. Then we will start the comparison. It's a simple linear regression model, simple linear comparison. How the functional group is changing, how the activity is changing. So what are those two informations, activity versus the structure? So what are the functional groups and different properties of the functional groups are changing. Based on that, how the property is changing, how the activity is changing. So simple correlation of structure, property, as well as the activity. So if you generate a standard correlation, then you'll get a structure activity relationship equation. That is a simple mathematical content. Y is equal to mx plus c. If you are a mathematics people, MPC people, then you know the equation of the standard statistical multiple linear regression or standard linear regression. That is a y is equal to mx plus c. Right in this, so what are the physicochemical properties which are having the influence on the activity? So those are physicochemical properties, that is electronic effects or hydrophobic or steric factors or Taft steric functions, molar refractivity, so Worlow steric factors. So these different properties, how they are involving in an activity, biological activity. So these properties will be analyzed here. So based on these properties, how to establish a SAR equation or QSAR equation, and also what is the difference between SAR and QSAR. So these will be taken care here. So as well as here, how to analyze the descriptors by using Crick plot or Topley scheme. So what are the bioisoesters by using regression or partial least regressions, so multilinear regressions, and different Hansch model or Free Wilson model to find out the QSR equations. So if you go with the multilinear or partial least square method, PLS methods, so what are the terms, conditions are there, what is N, what is SD, what is R square percent, F, Fisher values, so fitting values, how these values are there, how to analyze those values, how to use, how to find out which one is the best equations. So these will comes under in this area, and examples for the linear and non-linear equations, how to analyze this. And you have the practical in this area also. You have to go with the practical, but at present we don't have the situation to conduct any practical. But if you know, if you have the theoretical knowledge, then only you can easily go for practical knowledge, right? And the another one is, the last one is 3D QSR, because in SAR studies, the previous one SAR is the benzoic acid derivatives, we can conduct a SAR method. Then it is quantified by using the y value, that is a y is equal to mx plus c. Then establishing the quantitative measurement, how much it is. So that is a quantitative measurements. So in these quantitative measurements, if you go with theoretical only the properties, then that is called as 2D QSR. If you get the 3D properties of the molecules, means receptor and binding cavity positions, then it is called as a 3D QSR. So till 6D QSR it is having now, but in our syllabus we have to conclude with the 3D QSR methods. So under 3D QSR, COMFA, COMCI is there. So what is the difference between 2D and 3D QSRs? Everything comes under here, all right? And the next unit, that is a drug designing methods, that is a structure based one. So this is complete entire the unit area is the wide area, but here we are confined into a small area. But it is a complete informatics. So in and out of the range of informatics is available here. If you don't have the biological information, if you have the sequence of the protein, so how to establish a sequence, how to generate a structure from the sequence, so what are the different methods are there, how to optimize the theoretical structure in your computer. So what are the quality measurements we have to maintain, how to evaluate the models, how to find out that active site, means that where the molecule will go and binds, that is called as active site, means functional region. So everything will be conducted, everything will be identified. And what is the docking procedure? So in structure based drug designing, the docking is the most important method. So docking and virtual screening, so how many algorithms are used in the docking methodology, so what are the algorithm, what is the difference in between those algorithms, and what is the screening methods, that is called virtual screening, means rapid analysis of the bulk level of molecule. If you have 100 molecules, then you can go easily one by one to analysis in a 1 or 2 day. If you have 1 lakh or 10 lakh molecules, then it will take months of the time to analyze. So to solve that problem, there is a method called virtual screening, means we can generate a conditions. So which conditions are available, so based on those conditions, data will be analyzed, and it will be the rapid content. So 1 lakh molecules can be analyzed in 1 or 2 days. So that is called virtual screening. So different types of virtual screenings are there, ligand based or structure based or pharmacophore based, means different modes of analysis. So rapid analysis in different modes, those are called as virtual screening methods. So in this we have the de novo ligand design and its a limitation. So from the scratch, how to establish a molecule, that is called a de novo. De novo means newly and from the scratch. So right, so these are the different types of informations. Okay, and the other ones are structure based NMR, and two topics are, you have the topics completely, those are organic topics, so I don't want to go with that. So under my concentration I have the 4 plus 4 8 units of your paper. So due to these 8 units only, you have the pharmacoinformatics. So whatever the soul of pharmacoinformatics, the leading computational techniques, so will be available in these 8 units, and rest another 4 units are available in your 4th semester as biopharmaceutics. So there you can, here it is a topic of drug designing in the outside of the system. In your 4th semester you have the first paper, so how the drug behaves or how drug acts in your body. So based on those contents also, based on those knowledge also, we can design the molecule, means considering all those properties after the drug enters into your body, how it behaves, how it acts, where it goes. So based, what are the conditions, what are the driving forces. So based on that also we can design a molecule in the outside system. Because we are designing a molecule or a drug molecule in a computer, but drug has to enter a living system. So in living system, how it acts, if you know the information, then based on those conditions you can establish the molecule in outside. All right, so till now these are the topics what I want to go with here. So I'll take the computational chemistry, drug designing methods 1 and 2 topics, as well as the data sequencing and mining. So these are my units. Okay, right, bye, thank you for listening.